Okay, stats. Today's lesson and tomorrow's lesson are honestly the same exact thing. Today is going from point A to B, and tomorrow's lesson is going from B to A. So it's going forwards and going backwards. It is nothing crazy. So what that means though is if we get today's down really well, tomorrow is a very easy day. So you need some background information, which I will provide, and then we'll go from there. How many of you have taken the ACT? Guess what? The rest of you are going to have to this year. So you can thank those who put their hands up because they took a day last year where all the juniors got to sleep in or do whatever and not have to do school. And this year that's going to be you. And good luck. So when you take the ACT, you get a score. You get like your composite score, which is like, hey, I got a 22 on the ACT or I got a 27 or whatever it is. But then that does not mean that you got 22 in math and science and every other category there. It means it's an average of all those scores. So we do kind of look at averages a little bit, not much, but we mainly focus on percentiles. So if you notice here, and we look at percentiles very loosely today, and then we get more strict as the lessons go on. But like if I look at this math, it looks like this person is in the 49th percentile. So what does that mean? You should be able to tell me that. Yes.
Like if you put 100 people in a room, they would be the top 49. If I'm correct. Or they'd be the top 51.
No, they would be that 49 and below. Okay, so 51 people would have scored better in a sense. So that's what we're looking at there. Now, you did bring up something that's pretty important, is we do look above and we look below. So like we can ask you one question and we can change the word above and change it to below, and you now have two different problems. So we'll take a look at that as time goes on. I'm not going to spend too much more time here. Skip over that. Bell curves we care about. We talk about, we deal with a lot. Who's seen a bell curve?
Oh my gosh.
Who's in psychology? Is you? Oh, okay. Hopefully, you have seen a bell curve. All right. So, bell curves are pretty standard. If I collect data, and we did this actually for your final exam, we have a little bell curve from you. And so, typically, when you take a test, it's skewed because most people are doing well, and then there's a few outliers that drag kind of our distribution, so it's not a perfect bell curve. But in general, when we look at data, this is something that we commonly see. We see a lot of the data is partitioned very closely to our mean. Our mean would be in the dead center. And so I'm going to draw something here. That symbol is what we use for mean. You should draw that down too. You're going to use that throughout the day. And then we look at these different colorations. So I have the purple right here, and then it changes to green. So where that color changes, that would be what we would consider one standard deviation away. And so I'm going to put a 1 there. If I go to the left, I'd put a -1. And so that's just kind of giving me the direction of what I'm going. If I'm positive, I am to the right of the mean. If I'm negative, I'm to the left of the mean. And so for standard deviation, we use that symbol. Okay, so we're using some Greek letters here. We will use them throughout this unit. And I'm going to kind of connect this to something you just took. Need my markers. So on the whiteboard here, I'm just drawing a bell curve. And you also will be drawing a lot of bell curves today. And your bell curves don't have to be anything fancy. That's not very fancy. What I would anticipate, though, is for that bell curve, you have to put your mean in. Now, what do you think the mean was on your final exam? Let's hear some numbers. Ben, what do you think?
46.
46%? Not you. 41. What do you think?
Oh, I have faith in people and say 65.
Good for you. Sometimes you don't have faith. But, all right, here we go. So our mean was 52% approximately. Now, a lot of you got a curve. So basically what happens when we curve this is what should have happened is I would actually kind of ignore this curve, and I would just draw a new one. And it would look something like this. And basically, what we did is we took your scores, and we just pushed the whole bell curve over. Okay? And so we made the new average 70%. So then people had quite the jump, almost 18%. Actually, I was a little generous and feeling kind of lazy, so instead of 18%, I actually gave you 20. Now, here's the deal with that, though. We actually didn't end up with a normal bell curve. Why do you think we didn't end up with a bell curve? We ended up with something instead. That was skewed like that. Why did these people get stuck there? They didn't get the curve. Now, I normally don't call people out on the first day, but I cannot actually believe how many people didn't get the curve. I had about 34% of people did not get the curve on my section. That got hurt. We're going to move past that because the other 60-some% did a nice job. So just realize that. But your curves are going to look something like that. So here's the deal with it. The mean cuts your bell curve straight down the middle. It cuts it in half. So you got 50% to the left, 50% to the right. If I look at my standard deviations, we have the what is called the empirical rule, and we got 68, 95, 99.7. So if I look one standard deviation to the right and to the left, and I look at the area under that curve, it is accounting for 68%. That's what these numbers are down here that you have. So if I go 2 standard deviations across, then I am looking at 95%, and then so on and so forth. Okay? So just some background knowledge with the curve, nothing too crazy. But this kind of leads to something. If we know what the standard deviation is, and let's say I'm looking for someone's score, and I know that they were 1 standard deviation above the mean. It's very easy for me to calculate the percentile, because I know that I'm going to draw my own curve here. I know that 50% of the data is right there. And if I go 1 more standard deviation, how much percentage is in that category based off the chart that's right in front of you? 34. So I just add those 2 numbers together. And so I'd be in the 84th percentile. That's pretty easy. And if I did 2 standard deviations, it would be a very similar process. So I'd just go 34 plus the 13.5, that's right there. And that actually answer a question below. So we don't really care about the easy stuff. We care about the stuff that's slightly more difficult. And so what happens if I'm 1.25 standard deviations away? How do I figure that out? That's where this formula comes in. So you can actually write that formula right there on that purple sheet of yours, because you're going to be using that purple sheet. The formula, I give it to you on the test, so I really don't care if you have it written on the purple sheet. Plus, I give you a different Z table anyways for the test. So you can write that there, and it will be easy for you to utilize as time goes on. And then we're going to actually get into the problems of today and start answering them. And since you have it on your paper, I'm going to go to the next slide here. And so you can see this Z table, that thing, that purple sheet, has all these numbers. So half of today is can we calculate some numbers? Half of today is can we actually read this Z table to get the numbers or the solution from them. So we're going to start out with the math SAT scores. We give you 2 items of information, and this is pretty much always going to be the case. We're going to give you the mean, and we are going to give you the standard deviation. If we give you those 2 things, today we're going to look at giving you a score and you calculating some stuff. Tomorrow we're going to look at you actually calculating what our score should be. So here's how we start. I'm looking for what percent of SAT scores were above 625. So that means I'm going to use my Z-score to look in the chart and then give me a percentage. So I'm going to start by calculating what is my z-score. So I take my score, which is, in this case, 625, and then I subtract the mean, which is 500, and the standard deviation is what I divide by. Now, please notice, everything that is drawn in red basically stays the same for this problem. So I could change this number to 620, 615, 613, 200. It doesn't change anything else. I just rechange the number that's in black and I just do a new calculation. So now I want you to actually calculate that on your calculator. Some of you will get it right, some of you might get it wrong. And if you get it wrong, that's fine. You just need to fix it right now so I can help you. So everybody get a calculator, everybody try it out.
So that should be, do we round to the hundreds place?
You are going to round to the hundreds place.
Okay, then we have,
There should be... Oh, such a good question. Do I want a fraction?
no.
Students that have had me last semester know that I always want a fraction with the asterisk right there. Every once in a while, we don't want a fraction. This is one of those times. We don't want the fraction because your z table, I'm going to borrow this, is all decimals. So we have to use decimals for it. So what do we get when we calculate this?
89%.
No. What's our z-score?
Oh, z-score.
1.25. Are we good with that? Okay, if you did not get it, that is fine. I just want to make sure that we do, because now is the time to fix that up. Anybody? All right, so 1.25. So your z-table has two sides. It has a positive side and a negative side. So for this, I'm going to go look at the positive side. All right? So I first start by finding 1.2. And so that is right there on my z-table. And so if I'm you, I'm not drawing so much on my z-table. I actually will just lay my pencil flat across the paper. You can do it however you want. I don't really care. And then I find 0.05, and then I just trace my finger down until I get where my pencil is, and that is my number, 0.8944. And I said 0.8944, that's a probability, not a percent, so we have to convert. How do I convert that decimal to a percentage? Multiply it by 100. So I'm going to just write that off to the side here. And no, I'll do it on the board since the video is going. So that score gives me 0.8944. So I times that by 100, and I get 89.44%. And that's not my answer. We actually started with the hardest problem first. This is why I will always have you draw a picture. I didn't draw a picture here. This is why I always have you draw it first. It's because there's a trap here. If I draw a little picture here, I'm looking at the mean, which is 500. I have my score, which is 625, so it is to the right of my mean. It's higher, so 625. And I draw that line up here. And then I got to focus on the verbiage, so above. So above 625, numbers that are above are to the right, so I'm looking at this area right there. What I found is I found the percentage over here. So that 89.44% is to the left, but I don't want to the left. So how could I find to the right? Subtract it from 100 is perfect. So this is the hardest thing that we do today. Instead of 2 steps for a problem, we end up with 3. So I call this, I'll choose another color. This is step number 1. Reading my table and getting my percent is step number 2. And then sometimes we have to go to step number 3, which simply is going to be 100 minus 89.44 to give me my final answer, which is 10 point. Yeah. 10 on what? Okay. 10.56%. Now, I talked about that we're going to get a little more picky on percentages as we go forward, but for today, that's our answer. That's all we're focused on. Can we calculate the Z-score? Can we read the table? Can we get our numbers? Can we interpret it correctly? Questions on that first problem? All right, the problem directly below it. Our score changed. So now we're looking below 445. I'm also going to do it differently than the last problem. I told you I always want you to draw a picture first, so I'm going to do that. So my picture looks something like this, little bell curve, nothing too crazy. My mean is right here. My mean is 500. So 445 is to the right or to the left of that number? It's to the left. So I'm just going to put a random bar here. And when it says below, that means I'm shading to the left. So this one is actually going to be very easy. It's just going to be calculate my Z-score and then go ahead and plug it in and get my answer. So I'm going to have Z equals 445, that's my score, minus my mean, divided by 100. Let's give me that Z-score. What number is that going to be? 0. I'm going to disagree. Negative 0.55. Any trouble getting that number? Then we go to our Z table. I go to the negative side. I know that I have to go down a little bit here. Again, you don't have to draw on yours. You can. It doesn't really matter. And I'm just looking basically for where does X mark the spot? Where is my column coming down and my row going across intersecting? And so I'm looking at negative 0.55. So I'm looking here. So I'm looking at that number right there. What is that number as a percent? 29.12. Thank you. So I'll put that down. And does 29.12 make sense? For that picture right there.
Yep.
And it should. And so what I want you to think about is this. This right here is 50%. So first of all, does it make sense that a score lower than my mean, which is to the left, is below 50%? Yeah, that should make sense. Because if 50% is right here, 10%, 20, those numbers are over there. Okay, 90th percentile is way to the right. So that does make sense. That kind of checks out. So anytime you actually have a negative Z-score, if you're reading it in just a plain way, a negative Z-score is always going to give you something less than 50%. A positive Z-score is always above 50%. Okay? Any questions? All right, then you have the opportunity now to do these two problems across. And I will throw this your way. First, this top problem actually helps you out with the one that's down here. And the bottom problem helps you out with the one that's up there. The other thing I will say is, please work together. Okay? Please always feel free to work together. Check your answers with someone else. So I'll give you a few minutes. Write that stuff down. See if you can calculate it and get those Z-scores. I'll be right with you.
this one has repeated, but I round to like 0.34, or I do 0.34.
If we look at that third decimal, do you round up from here to down?
Down.
Something I want to point out to you. So when we are looking at numbers, for the top and the bottom, they are repeating decimals because of the 3 on the bottom. So you're getting a third or 2/3 or something like that. I'm always looking at that third number. That's telling me, do I round up or do I keep the number where it's at? Okay. So when I look at the first one, it leaves me with negative 0.33. When I look at this bottom one, I do end up with 1.67. So when I am looking at these numbers, always look at the third. You pretty much always have to the hundredths place, okay? Especially if you're looking at a z-table. Some z-tables actually go further, so always have that, okay? So what percent do I get for this first one?
37.07.
So 37.07. I'll throw the picture up here. It would look something with my mean at 11. My score would be there, and I'd be shading like that. So I look at this picture here. Mean is again at 11, but now I'm looking at 16, and I'm going the other direction. And what is my percent? What is my final answer? 4.75. That is good. Now I will say, so 4.75% is the final answer. And that comes because I go 100 minus the number I get from my z-score, which is 90. Yeah.
It was 95.25.
Good. So this came from the table, but then it produces the other number for us. What questions do we have? We are doing one more problem. So we are doing this one. I actually don't really worry about this one anymore because we don't do a whole lot with it. So you don't have to worry about the very last problem. Now, your homework problems, you have some like the problems we just did. You have some problems that look like this. So the piece about this is knowing how the heck do I set it up? So let's just set it up. So today is all about calculating a z-score and then reading the table. Now, I know I'm going to have to do that, but I need to know where do I put my numbers, because a lot of people actually do flip-flop the top. they change it. It goes back and forth. So we just got to get good at identifying those two pieces. So what number, and feel free to read and take a moment to answer this, what number is my first number, and then what is going to be, I subtract, and then what's the last number?
21 minus 20.7 divided by 5.9.
So this is my standard deviation, this is my mean, and this is my score. And so that is good. Calculated, tell me what you get. We're going to try to make sense of it as we go along. What's my z-score around to? 0. What? 0.05 is all it rounds to. And this right here looks something like that. And what percentage do I get? What percentage did I score better than? 51.9%. So our z-score is positive, and we are above 50%. So that kind of makes sense. And if I think about it, I haven't gone very far away, right, from my mean. I'm very close to my mean. So it makes sense that I haven't really moved in terms of my percentile that much. Okay? What questions do we have? Go to your homework packets then. So I used to make people go through and approximate all this stuff, and honestly it became, some people were fine with it, some people got fixated on it and did not move past it. And it's not that big of a deal, so I will just give you this. If I'm doing an approximate mean, what you should realize is that the mean is always the dead center of a normal bell curve. So my mean right here, my approximate mean, I would say is like 100. Because like when I draw this line straight down, it looks like it's about 100. You could say it's 101, you could say it's 99. We're going to use 100 for it, okay? And I'll move this in just a moment. Now, how do I find the approximate standard deviation? Think about the bell curve that we have. I have one standard deviation, two standard deviations, and then 3 basically covers the whole dang thing, all right? It covers up to 99.7. So if we're approximating, that's probably good enough. So if I was going to approximate this, I would basically cut this into 3 equal sections. And you can see I didn't do the best job of that. But so if I had to approximate, that's how you do it. You won't have to approximate it, okay? I will give you the mean. I will give you the standard deviation, or I will give you the opportunity to calculate it using something else. So for this homework problem, just go ahead and use those numbers, and then you can do the rest of the problems. If you do have homework questions, please ask. Again, if you can finish this today and understand it, tomorrow you will be in a much better place. So I'll be walking around. Let me know if you got any questions. I'll be checking in with a few of you who I have